Dear students, I am Dr. Gunasegaran, Professor of Chemistry. Today, I am going to discuss the structure of an atom. Under the structure of an atom, I am going to discuss 4 different subtopics. Number 1, atomic theories. What are the theories which are giving explanation for the atom? What is the atom? The number 2, the dual behavior of matter, in this case atom. How atom behave as a wave as well as a particle, we are going to discuss. Number 3, quantum numbers. What are quantum numbers and how it is useful to predict electronic configuration. And lastly, electronic configuration, we are going to discuss. All matters are made up of atoms. This is the idea. It was in the minds of all scientists. The first scientist proposed a theory for that, scientific theory, that is Dalton atomic theory, proposed in 1808. The second theory, J.J. Thomson atomic theory, was proposed in the year 1880. Rutherford atomic theory was proposed in 1911. Niels Bohr atomic theory was proposed in 1913. Bohr-Sommerfeld atomic theory proposed in the year 1960. Finally, quantum mechanical theory, it was suggested by so many people and it was taking place between 1920 to 1940. So let me go one by one all the theories to give a clear idea regarding what is an atom, what is the structure of an atom. So first let me take now Dalton's atomic theory. So Dalton atomic theory, as I have already pointed out, it is a scientific theory given to study about the structure of an atom. Dalton atomic theory was successful to explain all the laws of chemical combination, law of conservation of mass, law of definite proportion, law of multiple proportion, law of reciprocal, law of combining. All these laws, it was very clearly explained by Dalton's atomic theory. Okay, let me give a very simple way, the theory. What is Dalton's atomic theory? An atom is the smallest indivisible particle of an element which can take part in a chemical change. Let me repeat again. An atom is the smallest indivisible particle of an element which can take part in a chemical change. Atom, it is a word derived from the Greek word atomio, means uncuttable or indivisible. That is the meaning. So that is from that only actually the Dalton proposed this. It is the smallest indivisible particle. But we know now, according to the modern theory, it is not indivisible, it is divisible. The atom consists of proton, neutron, electrons. So that will be discussing later. Okay. This is regarding for Dalton's atomic theory. Next theory, it was proposed by J.J. Thomson atomic theory. What is Dalton atomic theory? According to him, J.J. Thomson, an atom is a ball of positive charge. It is a ball of positive charge where electrons are embedded. It is embedded on that this ball of sphere. This model is called plum pudding model. Normally will be asked. Plum pudding model proposed by J.J. Thomson. So according to Thomson model has no nucleus for the atom. Okay, at that time, so no nucleus. It's only a sphere of positive charge, ball of positive charge, where electrons are embedded. So it is called plum pudding model. This is the idea given by J.J. Thomson in his atomic model. So what you are seeing, the J.J. atomic theory model, what you are seeing here in this. Okay, let me go for the next one. So here I want to give one information I already pointed out. This is according to modern theory, it is divisible. So I want to give some information here. So there is particles I have given here. Who discovered? Discoverer I have given mass, I have given charge. So electron discovered by J.J. Thomson, the mass in kilogram 9.1091 in 10 to the power of minus 31. The charge, we know it is a negative, so 1.602 in 10 to the power of minus 19 coulombs. Same way, the particle proton, it was discovered by Goldstein, the mass in kilogram 1.6725 10 to the power of minus 27, and charge again it is positive 1.602 10 to the power of minus 19. The next one, neutron discovered by Chadwick, the mass is 1.6750 in 10 to the power of minus 27. It is neutral. It is neutral. It is not having minus or negative positive. So this is the according to modern theory. So I have given here the particle inside. Okay. And one more information. Just I want before entering another theory. So atomic number, if you know, we mostly introduce that. Nothing but we know this. Total number of protons equal to total number of electrons. So in this case, now we have three information. One is isotopes. What are the isotopes? Elements having same atomic number but different mass number is called isotopes. We already chlorine 35, chlorine 37, isotopes. Isobars. Elements having same mass number but different atomic number, we call it as isobars. Same way isotones. Elements having same number of neutron, we will call it as isotones. Why am I giving this information? So coming for the atomic particles, you must know this is actually after discussing this is the modern theory. Okay, let me come back the next theory. Rutherford atomic theory is supposed to be a systematic theory based on experimental evidence. This is the first theory proposed based on experimental results. This is the most important information. So according to Rutherford, he conducted an experiment. It's called alpha scattering experiment. So by heating the element polonium, he emitted alpha particle, and this alpha particle is allowed to pass through the gold foil, thin gold foil, very thin. It is under nanometer. Then after penetrating, it is allowed to pass on the screen, detecting screen of zinc sulfide. So from this observation of how many particles are penetrating, how many is falling on the screen. So by counting this, he suggested Rutherford atomic theory, we will call it as. So let me discuss that. So here, I am giving this alpha scattering. What is happening in an atom, I am giving in this diagram. So there are three important points here taking place. So, kindly see here, most of the particles are penetrating without any problem. It is going. Most of the particles are penetrating through the atom. When the alpha particle is passed through the gold foil, it is penetrating without any deflection. A few, this is number one. Second observation by the Rutherford, a few particles got deflected. The third information is 1 in 20,000 particles got deflected back, rebound back 180 degrees. So these are the three observations he observed in his experiment. Just I am giving here. So this I haven't discussed anyhow. Let me read again. Most of the fast moving alpha particles pass straight through the gold foil. That's the first observation. That means the atom is a hollow empty space. Inside there is only one nucleus. Now okay, let me come first. Second information, some of the alpha particles were deflected by small angles. The third one is 1 out of every 20,000 particles appeared to be rebound, coming back at 180 degrees. So these are the three observations just now I have discussed. Now, based on this, Rutherford and propose a theory, we'll call it as Rutherford atomic theory. Okay, let me come. What is the first one? Postulates. According to Rutherford model of an atom, it is called as planetary model or nuclear model. Planetary model of an atom or nuclear model of an atom. Okay, if you call this model as a planetary model or nuclear model, because competitively question can be asked. Number two, second one. The atom consists of positively charged nucleus at the center. Kindly remember, the nucleus was discovered. The atom consists of positively charged nucleus at the center, surrounded by negatively charged electrons. Again, electrons revolving round the nucleus like planets revolving round the sun. This is the most important postulate proposed by Rutherford. So he's giving two information. One is, he's saying that In atom, there is a nucleus at the center, solid part. So electrons negatively charged is moving around the central nucleus. What way? Like that is planets revolving around the sun. So this is the second postulate. So this, since the like planet is revolving around the sun, he call it as a planetary model. Since the nucleus is present, he call it as again a nuclear model. Both model we can call it as Rutherford atomic model. This is the most important postulate. Okay, let me go for the third one. This is purely based on the experimental evidence. Most of the atom of the atom is empty. And the size of the nucleus, 10 to the power of minus 15 meter, very small. As compared to that of an atom, it is 10 to the power of minus 10 meter. So this is purely based on the experimental evidences, result. Because most of the alpha particles are penetrating without any deflection. That means the atom is empty. Most of the atom of the atom is empty. Okay. And the center is this nucleus. The size is very small. What is the value? Now he is giving the value 10 to the power of minus 15 meter. Very small. As compared to that of an atom. So when you compare to an atom, 10 to the power of minus 10 meter. So if you compare these two values, size of the nucleus, size of the atom is 1 lakh times greater than the nucleus. Imagine. 1 lakh times it is greater. This is the most important information postulate. Number 4. Electrons are revolving around the nucleus at extremely high speed in closed orbits, so that the centrifugal force, the centrifugal force arises due to the motion. Let me repeat again. Electrons are revolving around the nucleus at extremely high speed in closed orbits, so that the centrifugal force, that is given as F equal to mv squared by r, m mass v velocity by r radius, arising from this motion just balances the force of electrostatic attraction. Because center is nucleus positive and outer is negative electron, so it is attracting. The electrostatic force is acting between. The value is given F equal to Ze squared by r square. So there are two forces operating. One is centrifugal force due to motion. Another is electrostatic force due to the charge. So both forces are equal at these conditions. So the electrons therefore do not fall into the nucleus. This is again another important postulate of Rutherford atomic theory. So very clear. Okay. What is the drawbacks of the Rutherford model? What is the drawbacks? Now there are two important drawbacks here I want to point out. One is, it does not obey the Maxwell law of electrodynamics. What is the Maxwell law of electrodynamics? We state that the revolving electron should continuously radiate energy. The charged body, any charged body will always emit energy and hence lose energy. So when it is anything is emitting, automatically it will lose energy. As a result, its orbit should become smaller and smaller, and finally should drop into the nucleus. But it does not the case. Why? The Rutherford model fails. Why? Electrons are charged body, it is always emitting radiations. So after emitting, automatically it will lose all the energy. When it is losing all the energy, it should come and fall into the nucleus. Why it is not falling? No explanation is given by Rutherford. This is the one. The second most important drawback is, it does not explain atomic spectrum of hydrogen and other atoms. This is the most important drawbacks of the Rutherford model. Because during his period, hydrogen spectrum was discovered. So, but how hydrogen spectrum is obtained from an atom, it was not explained by Rutherford. It is a drawback of Rutherford. So what you are seeing here, it is the hydrogen spectrum. So I will be taking separately in detail, but anyhow, just see the hydrogen spectrum. So during this period, this hydrogen spectrum was discovered. Let me know how hydrogen spectrum is obtained. When electric discharges pass through hydrogen gas, hydrogen will dissociate to give atoms, atomic, that is atom, and these atoms will emit radiations, electromagnetic radiation, and this electromagnetic radiation, nothing but hydrogen spectrum, what we are. It consists of number of series of lines. One is Lyman series, Palmer series, Poisson series, Bracker series, Bevan series. So this spectrum, it is obtained during his period. But when he was studying about the atomic structure, again he fails to explain how hydrogen spectrum is obtained. So automatically we are in need of other model. Okay, now here during this hydrogen spectrum, now there are two persons. Ritz-Bohr equation was proposed to, that is, in order to explain this frequency or wave number of this particular line, an equation was proposed. It's called the Ritz-Bohr equation. Kindly students note this equation. Problem will be asked based on this, especially in IIT question paper. Wave number, this I will be discussing again when I am discussing theory. There is a hydrogen spectrum. Wave number is equal to 1 by lambda, that is equal to RH into 1 by n1 squared minus 1 by n2 squared. n1 is the lowest state, n2 is the highest state. RH is the Rydberg constant. RH is the Rydberg constant. The value it is 1.097 into 10 to the power of 7 per meter. It is the value. So what is the interesting information is, if you go for a line that is hydrogen spectrum, if the electron is moving from higher level to lower level, n2 to n1, we can able to calculate wavelength or wave number, which because this is the equation we can apply. Question can be asked based on this one. Okay, anyway, I will be discussing later. Now the idea here it is, we have, that is during the period of this, that is Rutherford, actually the hydrogen spectrum was discovered. But how hydrogen spectrum is coming out from an atom, explanation was not given by him. So in order to explain these facts, Bohr atomic theory was proposed. Let me first find out, give the postulate as usual, Bohr atomic theory, then I will go further. What is Bohr atomic theory? This is the most important theory. Each atom consists of a number of stable orbits. According to Bohr, each atom consists of a number of stable orbits or stationary states which are all spherical. That means each atom consists of a number of stable orbits, stationary orbits, which are all spherical, round. That is the first thing. Okay, this is number one. Number two. So these stationary orbits or shell, or even call it as energy levels, were numbered. What way? Starting from the nucleus to outwards as 1, 2, 3, 4, etc. and are called K shell, K, L, M, N, etc. respectively. That means when n equal to 1, K shell, n equal to 2, L shell, n equal to 3, M shell, n equal to 4, N shell, etc. So this is another most important postulate proposed by Bohr atomic theory. Third one. Each shell is associated with a definite amount of energy. Kindly follow. This is the most important concept, that is the postulate. Each shell is associated with a definite amount of energy, and the energy associated with the electrons correspond to the energy of the stationary state. So wherever electron is present, if in first level, energy will vary. Second level, energy will vary. So the position of the electron depends upon the position of the orbit, energy level. This is the most important postulate. Each shell is associated with a definite amount of energy. I am going to give you equation also. And the energy associated with the electron correspond to the energy of the stationary state. This is the most important postulate. In addition to this, one more postulate is related with energy. The farther the energy level from the nucleus, the greater is the energy associated with. That means when electron is very near to the nucleus or far away, if the nucleus, that is, the electron is far away from the nucleus, the energy will be is greater the energy associated. If it is coming closer and closer, now we'll think of energy will be less. This is the most important postulate of Bohr atomic theory. So let me 3 and 4 postulate, let me explain with the corresponding equations. Kindly have it in mind. So I am going to give a simple equation for energy of an atom. Kindly remember, Bohr has derived equations. Your level, I am not going to derive the equation. I am giving only the final equation. What the final equation is this? Kindly this you have to memorize. En equal to, that is energy of electron in the nth level. Nth level, it may be 1, it may be 2, it may be 3, it may be 4. Nth level, that is equal to minus E0 divided by N square. E0, the energy of the lowest level. N, the number of the, that is energy level there. N equal to 1, N equal to anything. It is the nth level, N square. So, but the E value is given already by him. What is E value? That is 1313.3 kilojoule per mole. In terms of kilojoule, that E0 value is 1313.3 kilojoule per mole, or in terms of electron volts, 13.6 electron volts. Both way we can express the energy. In terms of kilojoule, I can express. In terms of electron volt, I can express. Okay. Now, what is the interesting information here it is, I want to give now. Suppose I want to calculate when electron is present in the first level, what is the value associated? So I can calculate now. E1 equal to, N equal to 1, automatically minus E0, that is by N square. What is here? That is nothing but minus 1313.3 divided by 1 square. 1 square is nothing but 1. That means nothing but the value it is minus 1313.3 kilojoule per mole. This is the N equal to 1. When electron present at the first level, minus 1313.3 kilojoule per mole, or 13.6 electron volt. Suppose if the second level, if electron is present in the second level, what will happen now? Instead of here, I can now here, so I can now, that is I can write 2 square here, because and the second is, it is 2 square, N square means here N equal to 2, 2 square means, that means 2 into 2, 4, so you divide by 4 here. In fact, when you divide by 4, approximately minus 3, 2, 8. So it is approximately minus 328 kilojoule per mole for N equal to 2. But if equal N equal to 1, we know already minus 1313. Now you can have a very clear idea regarding the postulate given by him. When the electron is far away, the energy will be more. That is the postulate given by him. Electron is far away means N1 is the nearest to the nucleus, negative, more negative, less value. When N equal to 2, it is far away from the nucleus, less negative, more value, it is more, the energy will be more. So, when electron is present the nth level, 2 level, E2 energy level, it is greater than U1. So, with this same way, we can calculate. This is the most important information. And also, if an electron is present in an atom, now the orbit, we will call it as an orbit. The size of the orbit can be calculated. Again, the Bohr has given an equation. The equation is Rn equal to R0 by N square. That is the R0, that is into, is not by, into N square. R0 into N square. Where R0 equal to 0.529 Armstrong unit. 0.529 Armstrong unit. So what the important information is, if you know the position of the electron in an orbit, we can be able to calculate the orbit size, radius. Okay, what is a very simple example? R0 value is 0.529. That means if the electron is present in the first level, it is 0.529 into 1 square, nothing but 1 into 1. So the first level, the size is 0.529. Suppose if the electron is going to the second level, so second means it is, I can write instead of 1, I can now write it is 2. So 2 square, 2 into 2, 4. So you multiply 0.529 into 4 means it is again the value will increase, the size will increase. So when electron is moving in again the size of the orbit going on increases. This is the most important information regarding the Bohr atomic theory. Okay, I hope you have clear. So we know, if you know the position of the electron according to Bohr, we know the energy associated. we know the correspondingly the size of the orbit. I have already pointed out in the equation En equal to minus E0. E0 is nothing but the energy of electron present in the lowest energy state. That means lowest here, n equal to 1. The same way, Rn equal to R0 into n square. R0 is the size of the orbit in the lowest orbit, nothing but n equal to 1. So we have to assume in both cases E0 lowest n equal to 1. R0 again n equal to 1, that value. I hope you have a clear idea. Let me go to the next one. So fifth postulate. An electron does not radiate energy as long it remains in the same stationary orbital. Remember, an electron does not radiate energy as long as it remains in the same stationary state. This is the answer now we are giving for the drawback of the Rutherford. Because the question here is what are the drawback? It is not obeying. The electrons are negative. It is going on emitting radiation. Then automatically after losing all the radiation, it should come and fall into the nucleus. Now the Bohr is giving very clear idea. Electron does not radiate energy as long as it remains in the same stationary. If electron is the n equal to 1 first level, it will not emit. Second level, it will not emit. So it is going on revolving the same orbit without emitting radiation. So emitting up when it stops, only if it jumps from one level to another level. Very clearly, Bohr has given a clear postulate. So radiation will take place only when it jumps from lower to higher or higher to lower or going from lower to higher. Only radiation takes place. If it is moving in a stationary stable orbit, then it will not emit radiation. It's a very clear postulate to answer for the Rutherford. Okay, next one. The sixth postulate. The angular momentum of an electron moving around the nucleus. The angular momentum of an electron moving around the nucleus is quantized. We can calculate. Quantized as it is equal an integral multiple of h by 2 pi. That is, m is equal to given mvr is equal to nh by 2 pi. This is the most important information. Let me read again. The angular momentum of an electron moving around the nucleus is quantized as it is equal to an integral multiple of h by 2 pi. Okay. Next. The seventh one. Now we are giving a clear idea. Emission or absorption of radiation occurs. That is, when electron will jump. Emission or absorption of radiation occurs only when electron moves from one level to another. The radiation is emitted if the electron moves from a higher to lower level, and the radiation is absorbed if the electron moves from a lower level to higher level. So absorption taking place if electron moves from lower to higher. If it is emission takes place, electron moves from higher to lower. So how this is you can imagine. Suppose I am sending energy, giving energy to an atom. So atom automatically will absorb this energy. After absorbing energy, what will atom will do? So electron present in atom will, after getting this energy, will be getting excited, moving from the lower to higher level. Automatically, the radiation, there is absorption taking place. It's moving from lower to higher level. So N1 it will go to N2 or it will go to N3 or it will go to N4, depending on the amount of energy it is absorbed. After reaching, it is not stable. What will happen? It will come down to the original state, lowest state. So what way? Whatever it is absorbed, it should emit. So by emitting, the excess energy is absorbed, it is coming back to. So this energy, whenever it is coming from higher to lower level, automatically emission takes place. I hope you have a clear idea. These are the postulates of the Bohr. So now just imagine, this is the Bohr atomic model. Here I have shown now here 3 level. That is level n equal to 1 first level, n equal to 2 second level, n equal to 3 third level. Suppose if it is given again even arrow is shown. This is the arrow is shown. Suppose I am supplying energy to an atom. The atom will absorb. The atom consists of 3 energy levels. Level 1, level 2, level 3 I have shown here. So after absorbing this energy, what will happen now? The electron is getting excited going to the next third level, let us assume. Third level it is assumed. After reaching the third level, it will not be stable. So it has to come back to the first, second level or third level, first level. So here I have shown second, it is coming to second level. So this difference, delta E, it is giving out in the form of an equation HV. That is H nu delta E. That means even we can be able to calculate how much energy will be released with the help of this equation. Everything I will be discussing under the hydrogen spectrum. So here the idea, you want to have an idea. So absorption takes place when the electron moves from lower to higher. Emission takes place when electron jump from higher to lower level. You can imagine. This is according to Bohr. Okay. What are the drawbacks again? There are again drawbacks. Again, Bohr is not able to explain all the facts, all the experimental evidences. Okay. Now let me go for first one. First drawback. It failed to explain fine structure of hydrogen spectrum. What is meant by fine? Kindly follow. In all books we given fine spectrum. So I have shown you the series of light spectrum, hydrogen spectrum. That is Lyman, Palmer, Brackett, Parsons, and so many things I have shown. In all the cases, you can see that is a line. A line was observed. A line spectrum. So according to Bohr, a line spectrum will obtain. What the line? Suppose the electron jumps from the level 1 to level 2, one line. Level 1 to level 3, again one line. Level 1 to level 4, again one line. So one line only we can get. Same way, emission, if they are coming from 2 to 1, one line. 3 to 1, one line, like that. So you will get only one line at a time. This is the idea given by Bohr. But what is fine? The same line spectrum, when it is placed in the magnetic field or electric field, it was observed. It is splitting further. We are getting a band spectrum. Kindly follow. Band spectrum. It is not a line. It is a series of lines. Band spectrum. So how band spectrum, that's called fine spectrum, we are obtaining, Bohr cannot explain. Failed to explain the fine structure of hydrogen spectrum. That's the first drawback. Drawback. The second drawback. It failed to explain the spectra of atoms having more than one electron. So what hydrogen is one electron? Hydrogen atom is only one electron, single electron. So, but more than one electron, any atom is present. But again, Bohr theory fails to explain the spectra. And Bohr's theory has no explanation for Zeeman effect and Stark effect. Just now I have explained it. What is meant by Zeeman effect? What is meant by Stark effect? When you place a line, that is line, in presence of magnetic field, it will split. That is called the Zeeman effect. If you place in the electric field, again it will split. That is called the Stark effect. So how the Zeeman effect and Stark effect, how it is getting splitted, it is not explained by Bohr. It is again drawbacks of the Bohr. So automatically, Bohr is also was also facing problems. So he could not explain many experimental evidences. So in order to satisfy the other conditions, so next person, Bohr-Sommerfeld, introduced another model called Bohr-Sommerfeld atomic theory. So let me go as usual, postulates of Bohr-Sommerfeld atomic theory. Let me discuss the postulates and the merits and demerits also. Number one, each atom consists of a number of stable orbits or stationary states, stationary orbits, usually represented by K, which are all elliptical. Kindly have it in mind, students. Bohr has given postulates saying that all orbits are spherical. And he has represented the spherical orbit by n value. N he has given. N equal to 1 first orbit, n equal to 2 second orbit, n equal to the third orbit, etc. So he used n. But now Bohr-Sommerfeld, it is now giving the values k. Instead of n he was using k. But another most important thing is he said no, orbits are not spherical. Orbits are elliptical. It is oval shape. Elliptical. Okay, let's go to the second postulate. So then next question arises. Okay, all are elliptical. Is that any spherical or not? Again, second postulate gives clear idea. There are n minus 1 elliptical orbits in each energy level. There are n minus 1 elliptical orbits in each energy level, and one of the elliptical orbit is spherical. Very, very interesting postulate proposed by Sommerfeld, that is Bohr-Sommerfeld. So according to him, all orbits are elliptical, but one of the elliptical orbit is spherical. What is the idea? So now I am going to give them, you have clear it. Suppose, now you can have an idea. Let me give an example. Suppose this is the n equal to 1. So according to Bohr, this is Bohr. This is Bohr. What Bohr-Sommerfeld? This is Bohr-Sommerfeld. So both are same. N equal to 1, identical. Nothing but same. Now, suppose, what about n equal to 2? What will be the Bohr idea? What will be the Bohr-Sommerfeld? But now only the problem. So in that case, when n equal to 2, so this is the Bohr. Left side is Bohr. That is the n equal to 1, n equal to 2. This is according to Bohr. When you come for Sommerfeld, now just see 1. So you have to give now. This is another. So this is n equal to 2. So one is elliptical and this is elliptical. This is spherical. So we have, so this is represented by k. We will use k1. This is called k2. So n equal to 2 this is. So k2 is nothing but n2. So this is the main difference between Bohr and Bohr-Sommerfeld. According to Bohr, all orbits are spherical. Whereas according to Bohr-Sommerfeld, all the orbits are elliptical, but one of the elliptical orbit is spherical. So in the first level, there is no elliptical according to Bohr-Sommerfeld. Second, only 1 because there are 2, n minus 1. 2 means 2 minus 1, 1. So if you go for 3, n minus, again 3 minus 1, that means 2. So 2 elliptical, 1. So this is the information given by, that is Bohr-Sommerfeld. There are n minus 1 elliptical orbits in each energy level, and one of the elliptical orbit is spherical. This is the most important postulate of Bohr-Sommerfeld. Okay, the next one. As in the case of Bohr again, the angular momentum of an electron moving in elliptical orbit must also be quantized. As in the previous case of Bohr, mvr equal to kh by 2 pi. There we have given the equation nh by 2 pi. Here instead of n we are using kh by 2 pi. That means it depends on k also. Okay, next one. The fourth postulate. The energy depends not only on n, but also to some extent on k also. Because, so it is, there is n, there is also k. So that is the idea given by Bohr-Sommerfeld. So let me explain this postulate with a suitable example. Let me compare both the Bohr atomic theory as well as Bohr-Sommerfeld atomic theory. This is Bohr. This is Bohr-Sommerfeld. Suppose this is the first level, n equal to 1 for Bohr. This is the second level, n equal to 2 for Bohr. The other side, we can now say this is the n equal to 1 for Bohr-Sommerfeld, and this is the n equal to 2 for Bohr-Sommerfeld. So according to Bohr-Sommerfeld, the second level, again n, that is n equal to 2, there will be 2 levels, that is n minus 1 elliptical orbit will be there. So the second level consists of 2, that is called the sub-level. So I will call it as this is k equal to 1, this is k equal to 2. That means the nth level, so when n equal to 2, according to Bohr-Sommerfeld, there are two levels, one is 2 levels, sub-levels. One is k equal to 1, another is k equal to, here k equal to 2 is nothing but n equal to 2. So if you are just considering the emission spectrum, suppose according to Bohr, if electron jumps from n equal to 2 from n2 to n1, there is one line. Whereas in the case of Bohr Sommerfeld, if electron jump from second level to n equal to 1, there will be two transitions. That is, one is coming from K1 equal to N1, another is coming from K2 to N1. That is, so according to Bohr, one line you will get. If you go for Bohr Sommerfeld, according to Bohr Sommerfeld, there will be two lines. One from K1 to N1, one line, K2 to N1 again, another line. So two lines. The same way, if you go for n equal to third level, again you will get only one line. If you are getting emission from n equal to 3 to n equal to 1, you will get only one line for Bohr. Whereas according to Bohr Sommerfeld, you will get, that is, three lines. Let me explain now. So there are three sublevels. This is k equal to 1, this is k equal to 2, this is k equal to 3. That is, k3 is nothing but n3. So you will get k1 to n1, one line, k2 to n1, another line, k3 equal to n1, third line. So Bohr Sommerfeld and Bohr very clearly I can differentiate here. Let me repeat again. So if we are considering transitions, if transition taking place from n2 to n1, only one line for Bohr, whereas in this case of Bohr Sommerfeld there are two lines. So that means there is a main n equal to 1 Bohr shell. So in this case, Bohr Sommerfeld K, another K will call it a subshell. So K1 will call it as subshell. So two shells. Then if you go for the n equal to 3, in the case of Bohr, there is again only one line, n3 to n1, only one line. So line spectrum. Whereas if you consider Bohr Sommerfeld, the third level consists of again subdivided into 3, that is k equal to 1, one level, k equal to 2, another level, k equal to 3, third level. So from k1 to n1, one line, k2 to n1, another line, k3 to n1 again for third line. So k3 here nothing but n equal to 3. So three lines we are getting for Bohr Sommerfeld. So k1, k2 are elliptical, k3 nothing but spherical. This is very clearly indicates that is the energy of an electron depends not only on n value but also k value. This is a very clear idea given by Bohr Sommerfeld. Now, the next postulate. The velocity of an electron in an elliptical orbit varies. The velocity of an electron in an elliptical orbit varies. This is again different from Bohr. The velocity is always constant because the same orbit, same radius moving. The velocity of an electron in an elliptical orbit varies, being greater when the electron is nearer the nucleus and smaller when it is relatively far away. So if it is an elliptical, there are two chances. It can come nearer to the nucleus, it will go away from the nucleus. So the Bohr Sommerfeld atomic theory postulate says the velocity of electron will be greater when the electron is nearer and smaller when it is relatively far away. So if you take this and if you go here, so the electron is here, very nearer to here, it is automatically, we can think of, it is the smaller, that is, the electron is nearer the nucleus if it is greater, so it is far away, it is smaller. That is a very interesting information. So let me repeat again. The velocity of electron is being greater when the electron is nearer. See, very nearer, greater, far away, it is smaller. This is the interesting information. Okay. Now what we are now shown here is the n equal to 4. N equal to 4, I have given the atomic structure proposed by Sommerfeld, Bohr Sommerfeld. So as usual, n minus 1, that is orbits will be there, that is the elliptical, we have to calculate. So n here 4 means 4 minus 1, it is 3. So 3 elliptical orbits it should be, that is 1 will be spherical, that we are saying. So K1 first elliptical, K2 second elliptical, K3 third elliptical, and K4 nothing but n equal to 4. So K4 is nothing but spherical, that is one of the elliptical orbit is spherical, that is n equal to 4. So according to Bohr, we are now saying it is, so suppose how to imagine according to Bohr. So this is first one, second, third, and fourth. This is the way we have to imagine for n equal to 4. But according to Bohr-Sommerfeld, so this is the idea we have to imagine. So this is the Bohr-Sommerfeld model of an atom. This is a very interesting information because with this help we can able to explain even the fine spectrum that we are going to see. Okay. Again, what are the limitations, drawbacks of the Bohr-Sommerfeld? This theory failed to explain the spectrum of polyelectronic system. What they had a single electron. Go for helium 2 electron, 3 electrons. So in polyelectronic system, the theory fails. It's not explaining idea. Now, this model does not take into account of repulsion between two electrons. Electron, negative repulsion will be there. So it's not taken into account of that one. It is not giving any explanation. So it's again a drawback, limitation. Then 3. Even though they suggested that angular momentum in closed orbit is quantized, they could not derive it mathematically. They cannot give support by derivation. It's only suggestion. It's only a postulate. So, now, even though they suggested that angular momentum in closed orbits are quantized, they could not derive it mathematically. Now, let me go for quantum mechanical theory. So we have starting from Dalton, then J.J. Thomson, Rutherford, Bohr and Bohr-Sommerfeld. They have come up. The final, satisfying all the conditions, is quantum mechanical theory was proposed. What the quantum mechanical theory says? Now, quantum mechanical theory allows uncertainty principle. This is the most important information. I am going to discuss again in second another heading, that is the hydrogen spectrum. I will be discussing in detail. So here let me just explain what is uncertainty. Uncertainty principle says it is in the case of microscopic particle, it is not possible to determine simultaneously the position and the momentum of an particle. For example, electron. It is not simultaneous. It is not possible to determine simultaneously both position and velocity, both position and momentum. It's not possible. That is the uncertainty principle. But quantum mechanical theory is taken into account of this principle, uncertainty principle, and suggested. Thus, these theories succeed to explain the behavior of electron correctly related to nucleus, unlike classical theory. So there are two theories explained to electromagnetic radiation, hydrogen spectrum. One is classical theory, another is the quantum theory. So classical theory fails, whereas quantum theory is successful because it is taken into uncertainty principle. Okay. Now, various states that are available to an electron are governed by laws of quantum mechanics. So quantum mechanics will propose some laws, and these laws are now giving a very clear idea how electron is present. Surrounding the central nucleus in various states. All this information is given by quantum mechanical theory. So this quantum mechanics proposed an equation that is called a very famous Schrödinger wave equation. What is this equation? So let me read this. Again, if you go for higher level B.H. or M.Sc, this equation we have to derive, but your level is not able. Just you can listen that simply just look into the equation enough. So let me read now. Dou square psi by dou x square, dou square psi by dou y square, dou square psi by dou z square, plus 8 by squared m into e minus b into psi divided by s square equal to 0. This is the Schrödinger wave equation proposed by quantum theory, quantum mechanical theory. What are the factors here? Psi is the wave function. Psi is the wave function. I will be explaining later again. Just what is the wave function? Right. X, Y, Z are three coordinate axes. M mass, E total energy, that is V potential energy. Then H Planck's constant. All the values are known. So, by introducing these values, whenever electron is present in any nucleus, and if you calculate the psi value, the psi has three values. If you calculate the psi value, psi has three values, or I can use the value 3 numbers. And this number I will call it as n value principal quantum number, L value azimuthal quantum number, M value I will call it as magnetic quantum number. So there are three values we are getting for psi. On solving this Schrödinger wave equation, for psi we have three values. The values are three numbers. So these three values are n, L, m. And I can call it n, I will call it as principal quantum number. L, I will call it as azimuthal quantum number. And m, I will call it as magnetic quantum number. Then next you can raise the question. What is this? Spin quantum numbers are how it is coming. Here just I want to give an idea. I will explain again in later in my another lecture. Spin quantum number is obtained from spectroscopy. It is not obtained from Schrödinger wave equation. So the spin quantum number is the value obtained from spectra. It is an experimental quantity. It is a derived that is it's an experimental quantity obtained from spectroscopy. With the help of H1 NMR and C13 NMR values, we can predict the spin quantum number. I will explain later. So the idea here it is solving this Schrödinger wave equation, there are already three numbers, that is principal quantum number, azimuthal quantum number, magnetic quantum number. The fourth one, spin quantum number, derived from the spectroscopy. With the help of these four quantum number, we can explain the atomic structure very clearly. Now, what you are saying now here, I am using that psi. I have explained you. What is psi? I have explained you is a wave function. What is psi square? Psi squared is nothing but it is the orbital. Psi squared is nothing but orbital. What is the orbital? Orbital is defined as a three-dimensional phase where the probability of finding that is electron is maximum. So it is around the central nucleus there will be some space where the electron is moving. That space we are calling it as orbital. So that size that is given by psi square. So now this orbital can be of many different shapes. So what we are saying is S orbital. This is the shape of S orbital represented by three coordinate axes x, y, and z. The next one. Now what you are seeing here it is the p orbitals. 3p, px, py, and pz. Again these are p orbitals. The shape is different. That is spherical. This is the dumbbell. The third one, that is d orbitals. There are 5 d orbitals. dxy, dyz, dzx, dx square minus y square, and dz square. There are 5 d orbitals. So here I want to give most important information I want to give. That is s orbital spherical. Whereas p orbital dumbbell. What about the shape of d orbital? Double dumbbell. Now, among these d orbitals, 5 d orbitals, the interesting information I want to give here. These three dxy, dyz, and dzx are, but that is these orbital between the axis it is present, whereas these two orbitals will be present along the axis. Why I am specifying here? Because when they are studying in +2 level coordination compounds, this information we must know. That's why I am specifying this. So now we have very clear idea regarding for this atomic structure. And I hope you have enjoyed